Okay, we are going to do our first confidence interval problem. So this is the Z confidence interval for mu. And I put the formula up here. Its formula is x bar plus or minus the Z critical value times sigma over radical n. Then I gave you those values for the important confidence levels, the Z critical values. So for 90% it's 1.645, for 95% it's 1.960, and for 99% it's 2.576. I vary my steps a little differently from the book. I'm a little more detailed, so follow along. This is what I want to see from you. So here's our problem. We want to find the mean pounds of overweight men. How many pounds overweight are they? Are they 25 pounds overweight? So we want to try to capture that. So we took a sample of 60 overweight men. It was a random sample too. Remember that I said that, a random sample of 60 overweight men. And I found from that my mean pounds overweight is 30, and we knew that the population of overweight men was 4.2 pounds. And we're asked to construct a 95% confidence interval for mean pounds overweight. All right, so since it said 95%, right there, I want to look at that. The number I'm going to use is 1.960 in that spot. So my step one is that I want to define what our parameter is. Mu is our parameter, and that is the population mean pounds overweight. That's our step one. Step two, remember those three assumptions from the last video. Assumption letter A, x bar is from a simple random sample. Hey, I said that at the beginning of this video. Letter B, n is large, and our rule is it has to be greater than or equal to 30. Hey, it's 60. 60 is good, so yes, n is 60. So we're going to pull a check here. Yep, we met that assumption. We met that one. And the last one is that sigma is known. Do we know sigma? Yep. They told us sigma is 4.2. So there we go. Step three, we're going to make a sketch. This is kind of a general, ooh, that looks bad, general sketch of a normal distribution. And I want to capture this mean. I'm going to capture it with an x bar. That's my point estimate. An x bar confidence interval. And it's a 95% confidence interval. So I'm just going to mark off the middle 95% of that distribution. That's kind of what the sketch is. So we've got our parameter mu, we have an x bar, and that's our a sketch of our interval, and then 95% in the middle. Okay, step four is our work. I'm going to delete, I'm going to get rid of this. Step four is our work. And here is our work. We are going to take those values. So instead of, let's write the formula first. X bar plus or minus, and this is standard, 1.960. That's our Z critical value, times sigma over radical n. All right, so what do we get from this one sample? We got an X bar of 30 plus or minus. We're going to copy that 1.960. Our population standard deviation is 4.2, and we divide that by radical n, radical 60. So I did the math of this part. I did that math, and that came out to equal 1.06. So that's 30 plus or minus 1.06. So that's our bound margin of error. That's what we're going to call that. All right, so if I subtract it on one side of 30 and add it to the other side, I get, I got to put a 2 here. I'm going to put 3 decimals there. I get 28.938 all the way over to 31.062. And I'm going to write in interval notation. So if you ever learn that in school, put a parenthesis, your left value, a comma, your right value, and a parenthesis. Okay, so that's our actual confidence interval that we constructed from that sample. So what does it all mean? I mean, that's we did capture it. We think we captured the truth. We hope it's there. But here's our conclusion: 95 of 100 intervals constructed in this manner will capture, we're all about capturing with confidence intervals, will capture the mean pounds overweight. All right, so what are the types of things that change in this conclusion? I like this wording, so I want you to kind of keep yours the same way. So maybe this number changes from a 90 to a 95 to a 99. Those words stay the same. We're going to do of 100 intervals. If I did this 100 times, we would think that 95 of them would work, and 5 probably wouldn't capture it. Okay? Constructing this manner will capture the true, well, maybe it's a mean, maybe it's proportion. For now, it's a mean. And pounds overweight is the context of the problem. Everything else stays the same every time. So maybe it's 90%, let's take out the percent here. I messed up. We could say 90 of 100 intervals constructed in this manner will capture the true mean ACT score, okay? 99 of 100 intervals constructed in this manner will capture the population proportion of people who like pizza. All right, so that's what we're looking at. So that's our first problem. Our next video, we'll have another one. And we'll look at how our confidence interval can get wider or narrower based on some of our values that we put in here.